Okay, doke. So we did some of this already, factoring. I don't believe we solved any last time, but you did it on the pre-homework, right? We did this on Monday. So solving equations, we're going to start off these first 6. We're just going to solve by factoring. So you've got to be comfortable with factoring. So to review, what do we do with this first equation? We've got 2x squared plus 17x and plus 21. What do we do to factor this? I heard it. Multiply the 2 and the 21. Excellent. And just do that off to the side somewhere. Now, this won't show up anywhere in your problem. I see a lot of people who are taking this number, which is, what, 42?
42.
I see them writing that over here somewhere. It has nothing to do with this. This is just some work you do off to the side. Once we get that that product 42, we say what factors of 42 will add up to 17?
3 and 14.
3 and 14. I'll take your word for it. I'm actually going to start a little lower because I want to talk about just a little bit about this systematic listing. You see, I always start with 1 and then go into 2. Will 2 go into 42?
Yeah.
Goes there 21 times. And I also always look at the signs. If this is a positive number, either they can both be positive or both be negative. Right? And what'd you say was the next one, right? 3 and 14?
Mm-hmm.
And you see that those add up to 17. 3 plus 14 is 17. So we rewrite this 17x as a 3x plus 14x. Because 3x plus 14x is 17x. Super duper. What do we do to this other stuff? Bring it down. So hopefully this is just a review. We covered this last time a little bit. And you did it on the pre-homework. So from here, once we've broken this into 4 terms, how do we factor it?
You group them.
We group them. We group these first 2. We group these second 2. And we look for common factors within our groups. So over this first group, for example, 2x squared plus 3x. Well, is there anything that will go into 2 and 3?
X.
Yeah, nothing will go into the 2 and 3, but we can pull out an x. Right, so the 2 and 3 stay in there. X squared becomes, yeah. So we take away that exponent, we're left with just 2x. The 3x, we pull out that x and it becomes just plus 3. So 14x and 21, 7? 7 will go into those? I hope. So 7 goes into 14 twice. 7 goes into 21 3 times. Now, have we done everything right?
So far as
How do we know?
Because the 2 numbers, the 2 sets are the same.
Yeah, there's 2 sets. The 2 things in parentheses are the same. They both got 2x. They both got the 2x plus 3, which is what we want. Because if they're the same, we can factor out 2x plus 3 from each of our groups. So when we remove 2x plus 3 from the first group, we're left with just the x. When we remove it from the second group, we're left with just the plus 7. And again, you did this a bunch in your homework. It's the only thing on here we didn't talk about last week. What do we do from here? What do we do with the 2 factors?
They equal, both equal.
Bingo. The only way these can be equal 0, the only way this product can equal 0 is if either the first factor equals 0 or that second one. And those are easy peasy. We've done those for a while. Subtract the 3 and divide by 2. This one we just subtract the 7. Exciting, right? How interested in are y'all in seeing this next one?
You just.
It's negative.
Wait, did I mess this up? Oh, yeah.
Yep.
Nice. So -7, x equals -7, or -3/2. Is this next one any different?
You just move the 21 over to this side.
Yeah. That's the only real difference here. You've got to move that 21 over first. And then you could solve it. How does this one work? Okay, actually we'll do this one because I want to show you something. When there's no number in front here to multiply by, you just got a 1 in front. This is actually way easier. So if I were to take that coefficient, 1, and multiply it by -21, I just get -21, right? What factors of -21 add up to -4?
-7, 3.
-7 and +3. That's actually our answer. Or those are our factors. It's nice how that works out. It only works when that leading coefficient is 1. You can skip all the factor by grouping steps and just get down to those factors. That's something you don't want to bother remembering. Don't. I mean, just do your normal factor by grouping steps. But that is a nice shortcut. And of course, we would have to solve this one. Right? Very exciting. So yeah, that only works when that leading coefficient is 1. We've got that 1x squared in the beginning. These we don't have a lot of work to do. I just want to go over some basic stuff. Like these that are already factored. What is weird about this one? The 5. So we would set this up as usual. We take each of the factors and set them equal to 0. But what is this? 5 equals 0.
It's not a possible solution.
Yeah, that thing doesn't have any solution. We still get solutions from these though. So no big deal there. What about when we have a 3x?
The same thing as the 5.
Same thing. We set that equal to 0. So we always just take these factors and set them equal to this 0. But this one we actually can do something with. Right, we divide by this 3. And what's 0 divided by 3?
0.
Any other ones? Nothing exciting there. All right, and these last two I'm not actually going to work out. I just want to talk about. Are we okay with this?
Did you do 6?
You want me to actually work it?
Or
I'll at least start it off for you. I want to start both these off. What do y'all suggest?
Put them in order.
Yeah, I would just rearrange these. I think that's actually listed in your steps here. Yeah, put in descending order. So that's the only trick here. This one, we've got terms on both sides, so we should probably get them on the same side. And I also want to write these in order. So 7x to the third plus 4x squared minus 3x equals 0. This one looks different than all the other ones we've done. What do we call this? They've all got an x in there. Do you have a word for it? Is it listed? I feel like it should be here. Nope. It's a common factor. Right? We have a common factor there of x. So you would factor that out. Oops. So I pull an x out of there. Instead of x to the third, I have 7x squared. Instead of 4x squared, I have 4x. And instead of 3x, just 3. Y'all want me to keep going? Y'all want me to factor this? All right, I'll do it. Okay, to factor. What do I do? I multiply that 7 and that 3, or that negative 3. And I get, can't see that. I get a negative 21. Now, since this is negative, that means I want one of my factors to be negative and the other to be positive. So I could do like negative 1 and positive 21, positive 1, negative 21, and so on and so forth. And I'm looking for factors that add up to 4.
That's 7 and negative 3.
7, negative 3. Does the order matter here? Should I be writing 7x or should I be writing negative 3x?
Negative 3.
It doesn't matter. What do y'all want to do?
Negative 3.
I'm going to do negative 3. I shouldn't. It doesn't matter. I just feel like 7 would have worked nicer there. But no, it doesn't matter. We carry down the other term. What about this x out in front?
You said equal to 0?
Yeah, eventually. Yeah, just don't mix it up with this. This has nothing to do with this. I would go ahead and like draw an arrow. This is going to get carried down in the end. If you bring it down early, I'm afraid y'all might get mixed up a little bit. So don't forget about it, but also don't mix it in with all this mess. Okay. So I've got my groups. What can I pull out of my first group? X. And my second group, 1. So not very pretty, but does it work?
Yes.
Yeah, I've got a 7x minus 3 in both of my groups. That's a good sign. So I pull out the 7x minus 3, and I'm left with the x and the plus 1. And now is when I would remember that x I carried down. Right, and then we need to set each of those equal to 0 and solve. I don't have a lot of room. I can just do it off to the side, I guess. Set x equal to 0. 7x minus 3 equal to 0. And x plus 1 equals 0. So that's solved. 7. There we go. Hopefully y'all got something similar. Maybe. All right. Are y'all familiar with this terminology, zeros? Oops. Find the zeros.
Yes, you just have to say the equal to 0.
Yeah, 4 functions. The solution to this equation, f of x equals 0, that tells us the zeros of the function, or the x value of the x-intercepts. Man, this thing's got a lot of names, huh? Or colloquially, we just say it's the x-intercept. This is kind of a silly point. You probably already noticed on like your, we talk about y-intercepts a lot. They want it as an ordered pair. This author is really kind of particular about that. When it asks for an intercept, this should always be an ordered pair. So once we find these zeros, I'm actually going to write out these x-intercepts as an ordered pair. On your test next Monday, when you're asked for a y-intercept, you're going to write that as an ordered pair. It's a little pedantic, but that's fine. All right, anyway, find the zeros means set your function equal to 0. There's my function, setting it equal to 0. Are y'all getting tired of factoring yet? Too bad. We got a lot of factoring to do in here. I'm going to go kind of quickly. You can always watch the video later. 6 times negative 5.
Negative 3. Negative 3.
That's 6 times negative 5.
10 and negative 3.
Factors? 7 apart. Oh, it's 10.
10 and negative 3.
Yeah. So that splits this up into a 10x, a negative 3x. I carry down my 5. Can pull out an x. Can pull out a 2. I'm left with 3x plus 5. That looks pretty good. Over here, I've got all these terrible negative signs. But we can just factor those out. I factor a negative out of each of these, and it becomes a positive 3x, a positive 5. Are we on the right track? Yes, we are. I know because I've got 3x plus 5 in both of my groups. And now I can set each of those factors equal to 0. And I don't have a little room. I don't have a lot of room, so I'm just going to write the answer. It is what? Negative 5/3. This is plus 1/2. Skipping steps like that's always a terrible idea. That's how you mess up your signs and stuff. That seems reasonable.
Wait,
Now,
is 0 still 1? Because of the 2x that you left over?
what this? This?
Yeah, that was just for that one, right?
Yeah, that was right there. It's only when we had an x in every term that we will have that x.
Hmm.
Like in this last one, we started off with x to the third, an x squared, and x. We were able to factor out that x in the very first step. That's what gave us that third solution. You all remember we talked about the fundamental theorem of algebra? X to the third is going to have 3 solutions. Squared is going to have 2. There's our 2. I don't know that we actually, I just want to go ahead and get into the habit of doing this. I know we do this in later tests. If you were asked to write these as intercepts, your x-intercepts would be negative 5/3 and 0, and 1/2 and Again, kind of pedantic, but that's fine. And then again, those are these intercepts. I feel like there's not a huge reason to do this one. Oh, this is one of the nice ones. Does that scare y'all? Because that's a 1. Whatever my answers are here, my 1 times 50 is negative 50. Whatever factors I get to add up to negative 5, that's my answer. And they are negative 10 and 5. Minus 10, positive 5. So those are my factors, my solutions. Again, I'm skipping all the steps today. I'm so sorry. That's a really nice little trick there. Yeah. That's a 1. Skip a lot of steps. You notice I also didn't actually write out these equations or solve them. I just changed those signs. We'll actually do a lot of that. I think it's test 3. For the most part, you can do that. A lot of these you can do that. It's only when you've got these extra, when you've got like a number in front of you, when you've got a coefficient in front of your x, then you're going to have to do a couple of steps. Move the 5 over, then divide. These, it's real easy. Just change the sign. Right? Because when you're setting up an equation, you're only doing one step. You're changing that sign. Right? Yeah, after you do a few hundred of these, you'll start skipping those steps. And you will do a few hundred of these. Get excited. Oh boy, okay. Quadratic formula. Y'all have this memorized?
For the most part.
For the most part. What about this discriminant business? Y'all had some questions on there about that. Does that make any sense? What do they even mean by that? The discriminant is actually just a term for whatever's underneath your radical. Yeah. So that's our discriminant. And it's really, for these problems, they're just asking if is that a positive number, a negative number, or a 0. I've actually got a chart for you on the next page about what's going on. If that discriminant is positive, you've got 2 real solutions. If it's negative, you've got 2 imaginary solutions. And if it's 0, you've got 1 real solution. Exciting, huh? There's some nice pictures of that too. I actually got a great YouTube video on this, but we're not going to watch it. 2 real solutions mean it has 2 points where it crosses the axis graphically. One real solution means it hits the x-axis once, and an imaginary solution means this thing doesn't cross the x-axis anywhere. We're also going to look at what this means algebraically on this very first problem. So going back to our first example here, we've got 4x squared minus 12x plus 9. Since this is written in the standard form of a quadratic, our a, b, and c are just these numbers 4, negative 12, and 9. So we identify those and then plug them into our fancy formula. What a mess. And I thought factoring was bad. Anything I should be aware of here?
This is equal to 0.
Does it?
Not the solution.
Okay, let's just go through these sign issues. What about this first thing, the negative, negative 12,
Positive.
positive? What about the negative 12 squared?
It's positive.
It's positive as well. I've seen a lot of people miss these. I think it's 144. It is 144. So if 12 is a dozen, you know what 144 is called?
2 dozen,
Anyone?
A dozen square.
144.
It's a gross.
Alright.
You ever heard of a gross?
Yeah, no.
You buy stuff bulk from China online. You buy it by the gross. Anyway. Okay, no other big sign issues. 4 times 4 times 9 is, I don't know what.
144.
144? Well, that's convenient.
Negative.
Oh no. Oh no. So I get 12 plus or minus 0 over 8. So before we actually work this out, what is our discriminant?
0.
0. What does that tell me about the solution?
There's one real solution.
1 real. Why?
It only intersects at one point.
What happens when I add or subtract? Algebraically, what happens when I take away 0? Yeah, I mean, nothing happens. This is just like I have 12 over 8. I have plus 0, minus 0. There's no difference there. So instead of having my normal 2 solutions, I've got 1 solution. And it's a real number, because those are all real numbers. We could take the square root of 0, it's a real number. 12 and 8, both real numbers.
You gotta simplify more of that.
We should probably simplify. What's 12 over 8?
3 halves.
Sweet. So not as big of a deal as it used to be, but I don't know. This is one of those bits of math that seems kind of pointless these days. It's not that much extra work to actually work it out.
You have to put that in parentheses. I mean, like X intercept.
When it asks for just the solution, no, we just want the number. Only when it uses that phrase x-intercept, that's when you have to use. That's when you have to write it as an ordered pair.
You don't put plus or minus in front of it?
Because the only plus or minus was right there. And plus or minus 0. So this seems to really throw the fundamental theorem of algebra out the window, doesn't it? I don't have 2 solutions. That is a bridge we will cross. We're doing test 3 material. Okay. Something to look forward to. Y'all want to do some more of these?
Yes.
Okay. So, can I do this the way it's set up? No. Why?
We're gonna move it. It's not in standard.
That's right. It's not set equal to 0. I've got to move this 5 over. I've got A is equal to 1. B is equal to
-2.
-2. C is 5. Plug all that in. Oops. I won't go through all those details. I won't ask all that. Negative and negative is positive. That's 4 minus 20. All right, what is my discriminant? What is the nature of the solution? 2 imaginary. But at this point, we would know that with one more step, right? What's the square root of negative 16? 4i. So you see, we've got our 2 imaginary solutions. 2 plus 4i, 2 minus 4i, but you probably are going to ask me, do we have to simplify it? Yes. Are y'all comfortable? Or do y'all I guess see what is happening? We're gonna take each of these and divide each one by this 2. So we get 2 divided by 2, and then 4i divided by 2. Right? Just like I can combine fractions, I can split them apart, and this time actually both simplify. Sometimes only one will simplify, and that's fine. But here they both simplify. We get 1 plus or minus 2i. And if my math lab doesn't like that answer, of course you could put it as 1 plus 2i, comma, 1 minus 2i. So 2 imaginary solutions. How is this possibly a meaningful question? Why would anyone care about management? Well, yeah, but why couldn't I just do the last 2 steps and do that? I mean, I had to do like that tiny little bit of work to figure this out. Now, I don't know if this is actually the reason, but this is a reason for this. Knowing the nature of your solutions and being able to cut out 1 or 2 steps of a problem reduces the computational complexity of a problem, which can make life really much nicer. Are y'all familiar with the Manhattan Project? That's how we built the nuclear bomb. If you look at the pictures of the Manhattan Project, it's just giant warehouses with people like y'all. Actually, it's people who didn't come to college. It's a bunch of, like, secretaries, basically. And each person would do 1 step in the problem. Like, one person would just change this sign. And they had just thousands of people working on this. Passing paper to paper, paper to paper. So every step you can eliminate is actually kind of nice. In reality, is this really useful for most people? No. Being able to save these 2 steps, 3 steps in order to figure out you're going to have imaginary solutions that aren't really useful in some cases. Like if you don't want imaginary solutions, you want to stop working this as quickly as possible, well, that would be very important to be able to eliminate this part, and just do that. So a little bit of background on why you would ever do that. Here, I think we just include it. Honestly, I think we include it for historic value. A lot of things just don't change in math because no one wants to change them. But it's a good thinking exercise, right? You should be able to figure that out. If this is negative, it's going to be an imaginary solution. It's kind of a thought experiment. All right, I'm just rambling now. Do y'all want to do some more of these? No? All right, we'll skip those last 2 and get on to these word problems. And these should look familiar because they're in your homework. Do you imagine if your job was to sit in a warehouse and add 2 numbers and cash and paper? Add 2 numbers, cash and paper. That project took years.
I feel like it'd be a relatively easy job, though.
Depends on the pay.
Easy, but easy but tedious. Imagine they probably had to stand in security checkpoints for like an hour every morning. Okay. This should be pretty easy. I know y'all don't like it. Does anyone not like this? Why? They've got a formula, right, with 2 variables, s and t. What is s?
Distance.
Distance in feet. Okay. What is t? Time, probably. T is always time. But we can look at it. T is an object falls freely from rest in t seconds. Okay, so t is in seconds, and it's the amount of time that this object is falling, yeah? Super. So we've got 2 variables.
One is already given to us.
One is given to us. Which one did they give us?
The height.
The height, which is
Distance.
s. Distance. distance in feet that an object falls, that's what height of this building is going to be. Of course, we'd actually have to read this last part. How long would it take for it to fall from the top? Well, it's going to fall the height of the building. 12, 9, 2. So that's easy. I've been told we're not supposed to tell students something's easy. But I know you can do it. Right? How do we solve it? How do we get rid of a square?
Square root.
Square root. We should probably move this 16 over first. Although, I guess we don't really have to.
Yeah, it doesn't come out a good number.
It doesn't come out nicely.
80.75.
Whew. That's not too bad. Could be way worse. Okay, you already told me this, but tell me again, how do I get rid of this square? Square root. And if you thought 80.75 was bad,
8.986.
what is it?
8.986.
Probably a lot more decimal places.
Yeah.
Boom. Word problems really shouldn't be bad. You know, they'll give you a bunch of variables, or when they give you the formula, these should be the ones you relax about, because they're just going to tell you something to plug into the formula and then solve for the other thing. These will be the nice word problems. This is the bigger pain. One number is 2 greater than another. I know I've got two numbers. One is 2 greater than the other. How can I write that? 2 greater, 2 more than. Any suggestions?
12 and 14.
Can you tell me this, how you could write this with a variable? I like it. We'll do x plus 2. One of them. Does this make any sense?
Yeah.
There are other ways to do it. I heard someone say, call one of them y. And if we say this is 2 greater than another, then we would say like this equals. If the other one is x, then this one would be y would be equal to 2 more than x. Yeah? I don't like to introduce an extra variable if I can get away with it. I got 2 numbers, x and 2 more than x. The product is 168. What is product? Multiply. Is means equals 168. We already came up with our numbers. We've got x and x plus 2 or 2 plus x or whatever you've written. And now you can solve it. How? I don't know. Suggestions.
Multiply the x by 7.
Y'all want to set each factor equal to 168?
Yeah.
Good, because you can't. I just wanted to get that out there, because I see people do that on tests and things. That rule only works. We can only do this if that has to be, we can only do it if that's a 0. So this has to be 0. It doesn't work with like 168. That's like if I said A times B is 15, A has to be 15 or B has to equal 15. Is that true? No. I could have A equals 3, B equals 5. There's nothing that says that one of them has to be 15. But anyway, we're getting off track. Yeah, we distribute, then what? Yeah, remember we want to get 0 on one side. I mean, we could move the 2 over, but we'd also have to move the x squared over, and our signs would be all jacked up. Of course, this isn't a great problem. But we have one reprieve. That's a 1. Thank God. Remember what happened? That's a 1. It just becomes way easier. I look at my factors. 1 times negative 168 is obviously negative 168. What factors add up to 2? Oh my gosh. I'm just going to guess some random numbers. That was just, I know you don't believe me. That was just luck.
You said earlier.
So there we go. But remember, since that's a 1, those are actually my factors. X plus 14. Actually, I don't have to go through all the whole mess of factor by grouping. I've got my factors, and so I also have my solutions. Now, if I recall, the way this problem is phrased, it says find a set of positive numbers and a set of negative numbers whose product is 168. Because you notice 12 times negative 14 is not 168. I could do 12 and 14, or negative 12 and negative 14. Right, positive and positive make a positive. Negative times negative make a negative. Fun stuff, huh? Ooh, I don't remember this one. Diagonal of a laptop screen. I will draw a laptop screen. This doesn't look like a laptop screen. Diagonal. 26 inches long. Its length is 14 more than the height. How can I write that?
14 plus 10.
I guess that means this is the height. Find the dimensions of the TV set. Well, how am I supposed to relate these things together? Very nice. Ooh, this looks like it's going to be a real pain. So what are A, B, and C? It doesn't really matter as long as we say that the hypotenuse is C. We'll call this A and call this B. So we get a big mess. I really don't want to do. How do we deal with the 14 plus h squared? That's something that'll actually be on this test y'all are going to have on Monday.
When you write them out, like factors.
It's on the computer, right?
Gotta multiply by itself. Yeah.
And it says square it, you multiply it by itself. You know, write 2 sets of them.
And then you gotta FOIL it.
And 4 like that. I'll do this other stuff. I'll carry it on the h squared, and 26 squared is just awful. $14 squared is 196. Outer terms are 14h. Oops. Inner terms, 14h again. And last terms, h squared. And we add another h squared. Right, we're carrying down that h squared. We've got some like terms. We can combine the h squared. We can combine the 14 h's. And this is a 196. How excited are you going to be to get one of these on your test? negative 480. Is that right?
Yeah, that's right.
What a nightmare. We can make this a little easier. You notice something about 2, 28, and 480?
So, 2.
Take out two.
Yeah, those are all divisible by 2, so I will pull out a 2. 240. That's a little better. Actually, it's a lot better. Now my leading term is 1. So whatever numbers I come up with, or whatever factors of 240 I come up with that add up to 14, those are my factors. Thank God. So what are those? What factors of negative 240 do I have? What is it? That makes sense. So it's a positive 24 and a negative 10. Thankfully, those are our solutions. So from here, technically, we should set each of our equations equal to 0, or each of our factors equal to 0. Oops. But we can eliminate a lot of these. 2 does not equal 0. What is the height of my TV, or laptop, or whatever we're talking about?
The highest, 10
Got a couple of possibilities. My height is negative 24. My height is 10.
That's 10. Can't be negative.
Yeah, we want that to be our height. Incidentally, this number is going to end up being a positive 24. Right? If I say, so we say h is 10, my length was 14 more than that. So 14 plus 10, 24. Just one of those great math coincidences. Now we take a break.